Tree diagrams. This is a great way to list the sample space for various experiments, particularly if there's 2 or more stages. We generally try and write probabilities on the branch arms. You can see that in orange at the bottom. We can write the probability outcomes, which you can see in blue, light blue at the bottom, and green is our label of the selection. So in the bottom case, P for patting dogs. I've got a bit of a stupid question here, but I'm hopefully showing you right now one of the questions from the textbook, so you can kind of use that as a guide if you want to pause here and have a look at that. But otherwise, let's get into Paprika patting dogs on the beach. So while I've got you here, obviously we've got the Super Zonti dog flying around there, and this is Fat Letzi. We dog sat for her for a little bit. She's a very overweight Labrador, but I mean, are any Labradors not overweight? Hard to say. Paprika enjoys long walks on the beach. She's found that she is 60% chance to pat the first dog she sees, but is then an 80% chance to pat the second dog she sees. She's a 50-50 chance to pat a second dog if she doesn't pat the first. Draw a tree diagram for this situation and label it. So hopefully you can see all that pretty clearly there, correctly labeled all of our probabilities. And we want to find the probability of Paprika patting 2 dogs, and that would simply be 0.48. And we found that by multiplying 0.6 times 0.8, and that gave us 0.48. So we multiply along those arms to find those probabilities. Find the probability of Paprika patting exactly 1 dog, so that would be P and not P, or not P and P, and we're going to add those together, which gives us 0.32. So adding those final outcome probabilities. Find the probability of Paprika having a bad day. That is obviously where she pats no dogs. Hopefully that isn't confusing. So 0.4 times 0.5 is 0.2. Sometimes we'll get kind of given that questions from these as well. You'll see those as we go. But that's my silly question, just so I could put some dog photos in here. Quite a bit going on in this question. You can see I've drawn out our tree diagram already, so I'm hoping that that's making sense. Again, writing those probabilities. In the green we have our outcomes, so that's pretty useful to have as well. So box A and B contain 4 counters each. Box A contains 2 red and 2 green counters, and box B contains 1 red and 3 green counters. So I simplified my fractions. 2/4 is of course 1/2, so that's just one of the changes that I've made there, but you could just leave it as 2/4. This is a little tricky. So if box A is chosen, what is the probability that a red counter is chosen from it? This is actually a given that question, so we're really doing probability of red being chosen given that A has already been selected, and that's simply 1/2. We're ignoring any other values there. We just do 1/2, which is really just looking at this arm along the tree diagram. If box B is chosen, what's the probability that a red counter is chosen from it? So same thing, we've already chosen box B, and we're just going to get 1/4 for this. We're just looking at this arm here specifically. So we've represented the tree diagram. What is the probability of selecting box B and a red counter? So that's B and then R, which is going to be 1/8, which we've already got there. And what is the probability of selecting a red counter? So that is either getting box A in a red or box B in a red, and AR is 1/4 and BR is 1/8, which that's the same as 2/8 plus 1/8, so we get 3/8 as our final answer. So just be careful with those given that kind of questions, a little tricky in the way that they're worded. A bag contains 5 blue and 3 white marbles, and 2 marbles are selected without replacement, so quite a change here. Draw a tree diagram showing all outcomes and probabilities. So you can see here, if we're selecting a blue marble, we start with a 5/8 chance. But then once we have selected a marble and we are not replacing it, we have a 4/7 chance of selecting another blue, as there's 1 fewer blues and 1 fewer in total. So our 8's gone to 7, 5 to 4. And with the white, we still have 3 white marbles in there, but 7 is our total, so 3/7. So be really careful with this without replacement kind of setup. I've left my final values, as you can see in green, unsimplified. We'll simplify as we go, but as we start adding these fractions together, it's probably easier if we have it as a common denominator. So find a blue marble followed by a white marble. So blue followed by white would be 5/8 times 3/7, which is 15/56. 2 blue marbles, so that's BB, and that is 20/56, which is 10 over 28, which is 5. Well, let's just change it here. 5 over 14, and exactly 1 blue marble. So where have I written this? That is going to be probability of blue and then white plus probability of white and then blue. That's exactly 1 blue marble. So BW is 15 over 56, and WB is again 15 over 56, 30 over 56, 15 over 28, and that's it. That's all we can do. If the experiment is repeated with replacement, find the answer to each question for part B. So here we are, the same table with replacement. You can see our 5/8 with B remains as 5/8 with B in our second kind of arm. And let's have a go at this. So BW would be 15 over 64. BB would be 25 over 64. Dodgy 6, can't stand myself. BW, 15 over 64. And WB, another 15 over 64. So 30 over 64, which of course is 15 over 32. And that is all we can do. And an interesting little question from the textbook. Nothing too crazy about it, just a bit of a different way of representing the information. So you can see we have this table, we've got these containers that hold marbles. There's obviously 3 containers. So our probability of choosing one of those at random is 1/3, 1/3, and 1/3. And then the selections along the arms of our marbles, which are 2 colors, purple and green. Purple in container A being 1, green being 3. So you can see where these fractions, or at least the numerators of these fractions, are coming from. Let's get into some questions though. So state the total number of outcomes. We can actually multiply our kind of number of arms along each section, each selection, to calculate this. So 3 times 2 is 6. We could add up our arms at the end, so PG, 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 so 6 there. Yeah, a couple of ways to do that. Part C, find the following probabilities. Probability of container A being selected and a purple is 1/12. So you can see that from our outcomes there. Probability of BG. BG is 2/12 or 1/6. I think I'll just do that. You probably don't need to see the other one. Probability of getting C then P is just 3 out of 12. So that's not too bad. Find the probabilities of obtaining a green marble. So that's all of our options, AG, BG, and CG, all added together. And that comes out to be 1/2. So really not too bad, just the setup was the challenge for that question.